Okay, so now let's look at writing hypothesis tests, right? The null and alternative with two samples, and then actually running a test. And so we have the setup here. We look at this situation, which you can see we're comparing college A with college B, and the proportion of students who drive from college A to college B. And so those are our parameters of interest, right? And we want to see, is it higher, right? Those who drive from college B higher than college A. So if we look at that, we want to look at some notation here, right? One thing we know, if there is no difference between those two schools, then the proportions are equal to each other. Or, right, when you subtract the proportions, it equals 0, right? That's important to understand. So if B is higher, then what we're really comparing is the proportion of B is greater than the proportion of A. And writing the null and alternative, we know that the null would be always with an equality symbol, right? Equals the proportion of A equals B. But we need to recognize that when we do, especially with StatCrunch uses a notation like this, where it's looking at the difference. Remember, that's what we focus on when we're looking at the difference between two groups. We subtract them. And then if it equals 0, they're the same. If it's greater than 0, then the first one's bigger, which I had made note of that at the beginning of the introductory section of this. Now, on example 4, so that's writing the hypothesis. Now we're going to take that, right, what we wrote, the null, that PB minus P equals 0, or that PB equals PA, and then the alternative. It's not stated, but we use an alpha of level 0.05 if it's not stated here. Now we focus on technologists because the hand calculations are really lengthy, tedious, and easy to make errors. So that's what we focus on. And so whenever we run a hypothesis test, it's important for me to identify the sample data, which you have here, right? You have the sample data. You're given the p-hats, right? 67% and 48%, but the x over n's, how to get those values again, we got those through how we did in the previous one. You're going to have to take 48% of 500 is 240, and 67% of 625 is 418.75. So that gives us a good approximation, right, of successes to total observations for our sample data. Because now we're trying to see if there's evidence, right, that is there really evidence that PB is higher, right? So we go through the tests. You have to do your requirements. We're going to assume those samples are less than 5% of all college students, right? Randomly selected, and of course it's large enough. We can see that through n times p, n times q, those two calculations there. And then we just go ahead and calculate a z statistic and p value. That's it. Now, that value, again, is going to be done through, we're going to use technology to do that. So let's head back to StatCrunch here to do that, and so we can compare that. And notice, again, within StatCrunch, as we run that, this is going to be proportion stats to sample with summary, and then we would go ahead and put those numbers in. So for one of them, right, for college B, we're going to put first because we're going to say that's higher. College B had 625 total. Sample size for college A was 500. Number of successes was 240. Let's peek real quick. There it is at 418.75, which goes here, the number of successes. And I got that again by multiplying the percent times that. And then we're running here. We want to see if it's higher, if the first one is higher than the second one. And so that would be our notation. And we click that button and compute. That's it. And when you do, you magically get the test statistic and the p-value. The p-value is really low here, right? Really low. It's so low, it just says less than 0.0001. So that's a very small value, which you can see I wrote here. And then with that, we can then go ahead and make a conclusion, right? Since the p-value is less than alpha, right? 0.0001 is less than 0.05, which was our alpha choice up here. We reject the null hypothesis, right? We're saying that's not true, and say we think this may be true, which then leads us to the conclusion, right? That the null hypothesis, right? We may have enough evidence, right? There's sufficient evidence to conclude that the proportion, right, from school B who drive is higher than school A because we rejected the null hypothesis.